right, so that's chapter 1. Chapter 2, be familiar with the atom, different parts of the atom, and know the terms atomic number and mass number. So are we familiar with all that? Neutrons, protons, electrons, and what is the atomic number of an element? Yeah. The atomic number is the number of protons. Good. All right. The atomic number is the number of protons in the nucleus of an atom of a specific element. Each element has a unique atomic number. Okay, so if you look at the periodic table, they're all numbered, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth, down the whole thing. That number is the number of protons. So helium has an atomic number of 2, meaning that helium has 2 protons in its nucleus. Hydrogen only has 1 proton in its nucleus. Lithium has 3, so on and so forth. If lithium were to gain a proton in its nucleus, it wouldn't be lithium, it would be beryllium. Because now it would have 4 protons in its nucleus. Does that make sense? So the atomic number is just, to simplify it, the number of protons in the nucleus of the atom. Okay? If it only has 1 proton, by definition, it is hydrogen. If you're looking at an atom and you look at the numbers of protons, say you're able to tell the number of protons in the nucleus, oh, there's 2. It would be helium. Good. So atomic number is the number of protons. The mass number is the number of protons and neutrons together. So if you add the number of protons plus the number of neutrons in one atom, then it's usually roughly double the atomic number. Okay? So, all right. So you see right about here, we've got another number on the periodic table. I'm not going to make you read the periodic table, so don't worry about this. I'm just using this as an example. Okay? So it'll have underneath the atomic number this other number, which is the mass number. So helium, which has an atomic number of 2, has a mass number of 4.0026. So about 4. About double. Right? Same thing with lithium, atomic number 3, mass number of 6.9. Almost, a little over. But, okay. So don't, if the periodic table part confuses you, get rid of it. Forget it. You're not going to need to know the periodic table. Just know atomic number is protons, number of protons. Mass number is protons plus neutrons. Okay. All right. Understand what isotopes are. What's an isotope?
They are atoms that have the same atomic number.
Mm-hmm.
Same number of protons but different mass.
Yes, that's right. So if they have the same atomic number, that means that they have the same number of protons. And if their mass number is different, that means that they've got a different number of neutrons. Okay? Good. The example they gave was, I think, oxygen. Oxygen has a number of isotopes. Right? So there's O16. This is just referring to the mass number. They have O17 and O18. They're all oxygen because they all have 8 protons in the nucleus. Because the atomic number of oxygen 8. But they all have different number of neutrons, so they are, because they're the same element, different masses, they're known as isotopes. So the mass number on here is 15.999. What the mass number is an average of all the different mass numbers in nature. And how common they are. Okay? So good. This example that we used is radioactive isotopes. Those are elements that have a different number of neutrons that are unstable because of this abnormality. And because they're unstable, they release energy or atomic fragments, known as atomic radiation, until they gain stability. And some are used to detect and treat disease. So, for example, people who have various forms of thyroiditis, right? If they were to have some issue with their thyroid gland, and their thyroid gland was making too much thyroid hormone, that's not a good thing for your body because it will put everything into overdrive, thyroid hormone. So, a treatment for that would be to kill the thyroid gland in that individual. Yeah. So, what they do is they would give radioactive iodine. Has anyone ever heard of this? Yeah? So it's iodine, but it is a radioactive isotope of kind of regular iodine that you normally see. And because it's unstable, and because one unique thing about the thyroid is it's the only gland in the body that will take up iodine, that uses iodine. So that's why they're able to use this one. Okay? So if they inject a bunch of radioactive iodine into this person who needs to have their thyroid killed, the thyroid will absorb up all of that radioactive iodine. That radioactive iodine will let off all of this atomic radiation to gain stability, but the effect of that will be it will kill the tissue. Okay? So that individual who no longer has a functioning thyroid will need to take pharmaceutical thyroid hormone, exogenous, for the rest of their life. Okay? But it's better than being super hypothyroid, right? That will have lots of problems associated with it. Okay? Questions on what isotopes are? Okay, nice. Be able to interpret the contents of a molecule by looking at the chemical formula. Ooh. Okay, so looking at the chemical formula, knowing what's in it. So an example here would be like this. These are molecular formulas. H2 tells you that there are 2 hydrogens in this molecule. Glucose has 6 carbons, 12 hydrogens, 6 oxygens, right? Yeah, that's just a summary, that's like an inventory of every atom that's inside glucose. Good. Same thing with water. H2O, there's 2 molecules, or 2 atoms of hydrogen, 1 oxygen. Okay? All right. All right, and then the different chemical bonds. Who can give me a summary of what you remember about the different bonds?
Ionic bond, covalent bond.
You're right. Those are good. Those are good ones. Ionic, covalent, peptide bonds, there's hydrogen bonds. Yeah, good. Good, good. And then within the covalent bonds, there's two different types within the covalent bond family. They're polar and non-polar. Okay? So we'll go through those real quick. Alright, ionic bonds is like it, just like it sounds like. There are ions involved. What's an ion? Yeah, it's basically any charged element. Has a positive charge, it's an ion. Has a negative charge, it's an ion. Ion just means it's charged in some way. If it has a positive charge, it's called a cation. If it has a negative charge, it's an anion. Okay? Ionic bonds are strong chemical bonds formed when a positive ion is attracted to a negative ion. It forms a bond. Okay? That's a very strong bond. It's a very, very, very strong bond.
Wait, can you go back real fast?
Yep. Alright.
Okay, we're good.
So here's an example, right? So we've got over here a sodium, and over here we got a chlorine. And what happens is this sodium is non-charged, it's minding its own business, and this chlorine, which is just minding its own business, what happens is an electron can leave from the atom of the sodium and go and latch on to the chlorine. Okay? That's just the nature of these. This will prefer more of a positive charge, and this one will be able to be stable in more of a negative charge. So it will more readily accept another electron. So if you have this electron, which is negative, and the sodium loses the negative, the resulting sodium will be positive, have a positive charge, because it just lost an electron, right? Similarly, the chlorine just gained an extra electron, so now it's not neutral anymore, it's negative. So the sodium would be a cation because it has a positive charge. The chlorine would be an anion because it has a negative charge. And then you got this positive, negative come together in perfect harmony to make an ionic bond. Okay? And you see this in salt, sodium chloride. Alright, covalent bonds is the next one that we're going to talk about. Again, these are strong, formed between atoms that share electrons. Okay? These are shared. So two atoms of hydrogen can combine to form a hydrogen molecule, H2. Both atoms in the molecule become stable. Same thing with oxygen. I don't know that I've ever heard of hydrogen atoms just floating around by themselves, because they're not stable by themselves. They want to have another buddy, so they'll float around in pairs, H2. Okay? Same thing with oxygen. It will float around with someone else. Okay? So usually, if they're just oxygen, they'll have two oxygens floating around, and they'll be sharing each other's electrons to make each other stable. Okay? So that's a covalent bond. But when you get the H2s together with the O2s, they react to form water. And this is an example of another example of a covalent bond between the hydrogen and the oxygen, where they share the electrons. Okay? So here's hydrogen. Hydrogen only has one. It wants to have two to be stable. Okay? So what they do, they solve this problem. It's like, hey, if I share with you and you share with me, it's like we both have two, right? Stable. Same thing with oxygen. And speaking of Disney World, oxygen is the same way. So they share things when they're by themselves, and then when they react to make an H2O, they'll get two shared with this guy and two shared with this guy. Because remember, the hydrogens want to have two electrons to be stable. You don't need to memorize the details of that. but just know the principle that they're sharing to become stable. Okay? That's covalent bonds. Again, you don't need to memorize anything about the specifics of hydrogen or oxygen. Okay? All right. And I don't know if this is going to be a thing, but whenever you see something written like this, each of the lines drawn, each of those is a bond, and it represents 2 electrons. Okay? Each line represents 2 electrons. So, just like we saw with the hydrogens, how they both shared their 1 electron so that they both had 2 that they were sharing, that's represented here. Because remember, a line means that there's 2. Oxygen has 2 lines, which means they're sharing how many electrons? 4 between the 2 of them. Yeah? So let's go back and just this picture here. Here's O2 right here. And you see they're sharing 4 electrons. Okay? Again, don't worry about the details, but I'm trying to just help you with, just in case you get thrown one of these formulas. Okay? And then 1 line between the oxygen and the hydrogen means that they're sharing 2 and they're sharing 2. The carbon and the oxygen and CO2 sharing 4 because it's a double bond. It's a stronger bond. Okay? Alright, so let's talk about covalent, polar, and non-polar. So, first of all, what do those terms mean? Polar and non-polar. Anyone else have any thoughts?
Is it polar? They exist between the same element.
Polar does not. It's the opposite.
Yeah, sorry, not polar.
Yeah.
Is the bond that exists between atoms of the same
Yes.
element.
Yes.
Polar is when they're different elements.
Yeah. Did you say polar? Yeah, you said polar. They were sharing unequally. Is that what you said? Yes.
So it's an uneven distribution. You've got 2 different elements.
Yes. Yes. That's it.
So hydrogen is a non-polar, whereas like glucose is a polar.
Yeah, so let's stick with hydrogen. So hydrogen by itself, just H2, that would be a non-polar. Because hydrogen and the hydrogen, those electrons between them are just right in the middle. There's no charge. So the polar thing, just the word means that there's a slightly positive end and a slightly negative end. It's polar. It's got a north pole and a south pole. Right? And so, water, on the other hand, where you've got oxygen bound to hydrogen, oxygen, just one of the properties of oxygen is that it's more electronegative, which means that it pulls those electrons closer to its nucleus than a hydrogen does, right? And so because of that, those electrons aren't right in the middle of the oxygen nucleus and the hydrogen nucleus. They're a little bit closer to the oxygen nucleus because it's pulling harder, right? And because the negative electrons are a little closer to the oxygen, then the oxygen side will be partially negative. And then the hydrogen side will be partially positive because the electrons are further away. Does that make sense? So yeah, you guys are both right. Yep. Not shared equally. Okay. Hydrogen bonds. What are these little guys? these are weak attractions of slightly positive hydrogen end of one polar molecule to the slightly negative end of a nearby polar molecule. Okay? So they're not very strong. And if we're between, example would be adjacent water molecules. So in your water bottle, right now, you've got a whole bunch of H2O molecules that are bound together via hydrogen bonds. There are these weak bonds. Okay? And between the slightly positive hydrogen end and the slightly negative oxygen end of the molecule. Okay? In protein structure and nucleic acid structure, this is important in how chemically everything reacts. Okay? Alright. So, that's the example there. Alright. That's all the bonds that we talked about. Questions on any of them?
Sorry, I just think if the video gets too long, it won't send.
Oh yeah.